going to present you the 12-factor cloud app in action. First, I would like to introduce myself. I am Ana Maria Mihălceanu. For short, I am Ana. I am an application developer at IBM Romania. In November, I got Cloud Application Certified Developer, so I got this. I'm a member of Technical Exchange Community Romania. That's an organization for exchanging technical topics between people in IBM. And you can find me at the Twitter handler that is showed on the slide. And today I would like to share with you some of my experiments on the cloud. And I would like to start this presentation by telling you about the 12 Factors app and how I got to the 12 Factors app. So everything started for me in November 2014 when I have done my first cloud application. And as many developers chose to do is to see a presentation about a cool thing. And I have seen a very cool presentation about IBM Bluemix, and I was, wow, I have to try this. And I was, in a hurry, so I have not read the documentation. I just went ahead. So I built a Java application, as I knew better to do at that time. And then I knowing what I've learned from that presentation, that was mostly a presentation with a lot of pictures and showing that with a few clicks you can make your own cloud application, and it's there and it's running and it's very easy. So just doing that, it took me about 1 day to put my my application into the cloud. And the reason why it took me 1 day is because I have not known some stuff about the cloud, and I have ignored some particularities about the cloud, and that I don't have to control some things that I used to control for my on-premise applications. And later I have discovered this methodology, 12 factors, and by applying it, I have improved my first application that took for me almost 1 day to make, and to have it on the cloud deployed there and running successfully. Since then, I have applied this methodology for any of my experiments. It doesn't depend on the language that I'm using or on the frameworks that I'm using. And today I'm going to share this with you and how you can build your own application by following these factors. So going further, I want to share with you the goals of this methodology. So the methodology scope, the end scope, is to have an application deployed on a cloud platform. This is what we want to have, a successful deployed application. But what it takes for us developers to have this successfully deployed? Well, for a good application in the cloud, you have to use a declarative format for your application deployment descriptor in order for it to run there. And by declarative format, you have to make your manifest in such a manner that you can read it actually, and you can know that you have in the cloud deployed application X that uses Y services, and it's very human readable. It does not depend on any other format existing. Another factor that is very important in their scope is to have a clean contract with the operating system. On the on-premise applications, there are times that we take into account the operating system, that we are thinking of it when we're doing our application, and that we have to also think of that when coding. Oh, it's going to be on Windows. Oh, it's going to be on Linux. And in an application for a cloud, this thing is completely ignored. You don't have to worry about that while developing a cloud application. Another scope of this methodology is to minimize divergence between development and production. I think we have all experienced the on-premise type applications where the development is poorly fed with resources, because us as developers do not need as many resources as a production application would need, or as many nodes, for example, for a server to be available in the development as would be in production. So by using this methodology, you do not need to think that your production is going to look different and to think in advance that you have to worry about how complicated it's going to look or how complicated it's going to be for you to have an application in production. And the last part is scaling up without significant changes. This means that once your code got into production and there's no way to get back, I mean, it was the full release and you have no way to intervene upon it, then you can scale the application in order to improve its performance, either vertically, either horizontally, or even auto-scaling. And I'm going to detail that in the slides further. So going next, I'm going to talk to you about the factors in detail. So the first and actually the most important factor that some of us might think, okay, it's normal. Everyone has a code base, so everyone has the code in revision control. This is nothing new. But what is new is that sometimes when you're doing the versioning part, you are missing. So when an application has many versions, a lot of decisions happen, like having many repositories in case of a Git. So this has been seen before and it happens. What I would like to tell you is that it is the best thing to have just one repository with many branches, as many branches as you want, but just have one repository, just spreading your code among many repositories and having multiple deployments from them just because, oh, it's going to be a code that the developer should never touch again because it's stable. This is not going to bring you any good for you as developers. You're going to get mixed up and you are going to have more trouble in understanding later why you had certain features on certain branches and why you don't have them at the others. Yes, you can go to requirements, but if you have like 4 versions of an application with many features and little versions between them, it's going to be very difficult for you to track all those and to think what deployment should you do when you have so many repositories. The most commonly used for the code base in case of the cloud is, of course, our best friend Git. It's the most used repository. Git, GitHub, GitLab, or Jazz. That's an IBM product. So any of those in combination with tools like Jenkins or Urban Code Deploy that are helping you to create your own build jobs or your own deployment jobs help you to have continuous integration. So this is the main aspect that you should have in mind. You want to have continuous integration. You want to do not think about what is going to happen if I don't know, if something breaks. You want to have everything fully managed by a third party, by the system, that you have no interaction because you don't want to worry about this. So keep in mind that having a good code base where you're getting many deployments, as many as you want for each of the environments that your application has to be deployed on, is the best choice in terms for a cloud application. About the dependencies. So dependencies, an application in the cloud relies on the implicit existence of the dependencies in the system. What this means is that once that your application got in the cloud and is going to build phase there up in the cloud, the application is not going to think about, oh my God, I have this dependency specified in a file system place like you used to have perhaps locally, because it's much easier for you locally to just declare a dependency and just just put it there in your pom.xml or ant build. So you should always declare your dependencies in a manifest file, depending on your language that you're choosing to write the application. So it can be a pom.xml file, like showed here. Bad resolution. Sorry. Or if it's a Java application, or you can choose, I don't know, an Ant build, but nowadays Ant is not so popular for Java applications or modern Java applications, because it's much easier to spot a dependency in a POM file or in a Gradle file than just look into all that Ant and see where your libraries are being declared, libraries/dependencies. Or in case of sorry, in case of a JSON application, you have the dependencies declared in the package.json. So as you can see here, so everything is being very structured. You can easily spot in your code where your dependencies got declared, so there is no possibility of leaking in any of those dependencies while building your application. Factor 3 is about configuration. So your configuration should be in the environment, but what environment? Since we don't want to be so aware of the operating system, where is this environment? So this environment is actually in the cloud. The configuration of a cloud application stays in the cloud environment, is globally available for you, the user logged into that cloud, because you have the right to be there. And you can access it in a manner that doesn't depend on the language that you're programming in. So for example, here you can see that I have such a configuration of a service. So here's the ClearDB service, having descriptions of the ClearDB is a database as a service offering that's actually based on MySQL. And you can see here the credentials that you can use to connect to a database, and also the cost plan for it, and any other things that might help you coding with this service in the cloud. So all of these can be found in the cloud. It's available there, and you just can get it very easily by just invoking it as just getting it either with the expression language. It's very commonly used, or you can invoke them with the system get properties in Java, or you can invoke it also in Node.js through global part. And the main reason to store the configuration in the environment is because it's easy to change, and you are not changing the configuration. You're not usually changing this configuration in the cloud. You're this configuration might change itself by the cloud providers. So for example, if something got wrong with your database, and there shouldn't be a human there knowing that something went wrong with your database as a service, it can be switched automatically without you to see that, and only the values of these labels can be changed, but your application is going to use just the labels in order to get the value. So this easy to change part, where you can read the labels to get the value, it's very good for your application, because it's not going to feel that little gap of the change between those databases. Also, this configuration is not in your code. So you would not need to check in and deliver your configuration like you used to do with the properties files. Everyone remembers the properties files for the Java, so we have to check in and deliver those. If you wanted to connect to a certain environment, and then to code your application in order to detect somehow, or to choose the deployment on which environment would you like to deploy it, and to choose between those variables. So this thing is no longer necessary in your code, because the variables exist there. They're just read through the label, and you're using them in your application through the label. They use their value through the label. And also configuration variables are also language and operating system agnostic. This means they do not depend on a certain operating system. You do not need to worry that they're going to look different depending on your operating system, and you have to read them differently because perhaps you will use, I don't know, Windows or any other thing. This is not your worry anymore. Reading your configuration based on the operating system. Next thing I want to draw you the attention to is the services. So even a simple application, even a simple CRUD application that only needs a database, for example, like in the slide, has to treat the service as a resource. This means that when you're coding your application, of course, you're going to code it locally, but it also has to run in the cloud. And your application has to always think to your database as a resource. And how do you actually do that is by configuring your application in such a manner that it doesn't need to worry about this. And I'm going to show through code how you can do this. So in case of the Bluemix application that is based on Cloud Foundry, for backing services and for binding a service to an application, you just simply have to use this command to create the service. Then you can push the application, and there's a very nice command that says bind, that binds the application to the database. So this way, by binding your service to your application, you are treating that database as a resource that can change, of course, at your own will. Also, locally, if you want to do the same thing, you're not going to have the Cloud Foundry commands, of course. But you can just do a little switch in your local properties, and it's going to be very easy to to run your application even locally. And the factor 5, that's about build, release, and run. So you should strictly separate the build and run stages of your application. So this is a personal recommendation of mine. I like to separate the build part of an application from the deploy part, because, for example, if something happens at build and is going to fail, I want to have a stage in between build and deploy that I can use, having the latest running build, that I can use to make further deployments on other environments. So I don't want to worry manually about getting the latest working build in order to deploy it. I want it to have it automatically available for me. And also, it's very easy for me to roll back by using this separation of the stages. And now it's going to be a little code break, and we're going to get some action. Hope it's going to work. Let me introduce you to my application. Hope it can be seen. It's not that nice. Sorry. My application, my Java application, I have chosen it to do it with Spring. It's quite easy. It's Spring Boot-based application, so it's a library application. I have chosen to make its config based on annotations, and it's with auto configuration. That's very easy. It has some services here with controllers, repositories, and entities to get the things from the database. So it's nothing complex. As I said, for my first factor, what matters is the code base. So for the code base part, I am using Git, where I'm checking, where I'm having my branches. And you can see here my Git branches. While for the second part for the dependencies, I have chosen Maven. And you can, 1 second. And you can see here how easy it is to isolate the dependencies for my application. It's more easy to be read. And you can go through them very easily to find what dependencies you need, and they're very well isolated. And also, for the third factor that was talking about the environment variables, well, those you're gonna see them on running. So I haven't stored anything about the variables in my code. I'm basing my code on the fact that I'm going to get everything when the application starts in the cloud, and I'm gonna get everything there at runtime. And my application is in Bluemix by pushing my code to Git and showing you my deployment pipeline. So here's my pipeline. where I have the build that receives, it's being fed by the Git URL. And in order to build, I've selected the build Maven with a profile, because I want to be built as a var. And then the release stage, that is just simply taking the artifacts from the build and my deployment. That is simply taking the release job that was on success. You can see here the stage release. It's being fed by stage release. And is going to push my application to the cloud. So let's make a little change to my code because I don't like something about it. So now my application is running in the cloud. Let me get the URL. Okay. So this is my application. Is not looking very nice, I know. But it's deployed in the cloud and I can access my service books. And you see here that I have a REST service that answers to me, and I want to filter from this one that those books that that do not have book info ID to set to null. Just making a little change to my code. Okay. In my repository, I just want to find distinct by book info ID that are not null. I'm just doing this, and the query is going to be listed. And also in my book controller, I want to do not get my all books. I just want to get my custom-made method. And you'll see how simple it is to just push this, and it automatically builds and gets deployed. Successful. Commit. Come with distinct. Okay. Commit. And push. Come on. What, I'm out of internet. Oh. Or I forgot my password. So all is there. Okay, so I push my code to the cloud, my changes to the cloud, and I want to see what happens. So I'm getting back to my pipeline, and you can see here that my build is running. So it just got my change, and it's going to do the build and so on, and I can supervise my build to see if it's going to be successful. If it's not going to be successful, then my release stage is going to protect what I have deployed, and it's going to show me the latest working build. See here the log, and so on. I'm gonna leave them to do. I'm gonna leave it to get all the dependencies and do its stuff. It's still running at 99%. Okay, and it's going to go through all these by automatically because I have configured this to run whenever a change is detected and to stop if it fails. And I'm going to show you that this one is going to be fed by build 99. See here, run jobs when the previous stage is completed. So all these are just linked. All this pipeline is just linked and goes further. Now, this is for Java, and some of you might think, okay, you've done it in Java, you have used Maven, it's going to run automatically, it's going to be deployed automatically, and the application is going to be pushed to the cloud. So what about if I'm not using Java? So for many people choose Node.js to develop because JavaScript is the newest cool thing to develop things on right now. So for JavaScript, for Node.js, I've created also an application having the same thing, the same backing service, but it's made with Node.js. So you can see here, as I told you before, my package.json where I've declared my dependencies. I have my code for the application here, and I'm getting my credentials automatically in the cloud. I'm searching for ClearDB. And you will see that the same thing is working here for the node. It's looking a little bit different with the UI. And you can see the books. Here are all the books, all 3 of the books and the owners for my service. So it's pretty much the same thing. In the build part, because it's not a Java-based project, I have easily configured it, and I said it's a simple build for Node.js. The release, because I want to be protected in case of failure in the previous one. And the deployment, it uses the same command, cf push, and it's going to still push my application. So there's no change. All these 5 factors that I've used before for a Java application can be used also for a Node.js application. And of course, I can edit my code here online, and I can run it directly, but that's some features that are belonging to the cloud. Okay, let's see how our Java application is doing, how it's built. So you can see here that the release stage has passed just now, and now that is deploying, and it's running the deployment. And you can see that the application has stopped a little bit. It's not available because it goes to restaging. When this is going to be over, it's going to get to the next deployment and so on. So getting back to the presentation and leaving that to run, I would like to discuss with you some factors that are more fine, let's say so. So what about the processes for a cloud application? Your cloud application should be executed as one or more stateless processes. What this means is that you should never rely on the cache of that application to store something. If you are trying to persist something, you should use a database, or a dedicated session caching service, or a dedicated data caching service. What this means is that if you are needing information that are stored on the session, and you need to have those available, if, I don't know, you have an online store and for some reason your application needs to restage, you have to get those back. So there are the services dedicated to session caching, and they're usually cloud provider dependent. So depending on the provider, you can get one of these services that can retrieve the session that might get lost during that restage. Or you can use data caching services that are pretty much the data caching services that we are being used, like Memcache or Redis, or even cloud provider based services. So you should never rely on that part of the file storage or anything else that might get lost when your application gets shut down. The cloud application should use the service via port binding. What this means is that an application in the cloud is completely self-contained and does not rely on runtime injection of a web server or an execution environment to create a web-facing service. What this means is that if normally on your computer you would have access to your application, let's say localhost 1880, you will see that on cloud you're just accessing directly the application via a root, because the cloud is protecting you from binding directly to a port. It's a matter of security, and you do not have to worry about what port or what context your application is going to be used. The cloud protects you from this. And you can export the services in your manifest file, and I'm going to show a little bit of my manifest. So the manifest file is the one that's the application deployment descriptor for the cloud. In the case of my Java application, it's pretty easy. It's using the declared services for a database called BookDB, and I've just specified the label of that service, that's ClearDB, and the plan for that service. And then I'm just detailing about my application. That's using a disk code, a host, a name, a path, and so on, and what build pack it should use. And also that is making use of the services called BookDB. So when this application gets deployed, it will automatically be binded to the service called BookDB by the cloud. It's not my worry to think on what port is going to access the database or on what host and so on. I'm just basing myself on the name of the service. And you should never try to control the database from the cloud by enforcing credentials in your code. It would be, I don't know, like breaking the factor number 3. Okay. Yes, and when you're pushing the application to the cloud, you can see this, that this manifest gets executed, and you can see that the code for the application is being downloaded, uploaded, and then that the application itself is being binded to the book in your space, and then the application gets restaged in order to start them both. Let's talk about concurrency. So in the cloud, you can happen to have the same problems that you used to have on premise about the concurrency. This is a very important topic for us developers, because if your application has to support like, I don't know how many thousands of users in the same time, this is a problem. And of course there is load testing and you can test a lot and so on. But what happens if you haven't tested enough and your application got deployed in production? And this is it. You cannot intervene to your code anymore. Let's say that you cannot intervene to your code anymore. What can you do in order to improve your application performance? And the answer to this is scaling. You can either horizontal scale by adding a node or an instance to your application, or you can vertical scale by adding more memory to your application, or more disk space. So for example, you would use horizontal scaling when you for sure know that you need a new node for your application, and you would use vertical scaling when you just need a little bit more memory to that instance of your application, not an entire new instance that it uses much more memory. And the disk space is very useful to having more space, let's say, for making certain logs or certain, it can happen to need more space and you need to scale vertically. Or you can auto-scale. So some clouds offer this service of auto-scaling, and you can just set up rules for auto-scaling that can detect automatically if you need at certain point in time to add more instances or just add more memory. So for example, if you do not need to supervise your application when it needs more instances or more memory, you can set up these kind of rules, and I want to show you a bit how you can do that in my, okay, so just showing you my auto-scaling. So for my applications, I have performed auto-scaling because I wanted to add more instances in case of more users, and because I was a little bit cheap and I didn't want to use a lot of memory. Come on. I need some internet to show you. What I want to say is that, for example, if at a certain point in time, there are more users accessing my application, okay. This one doesn't have. Work. Okay, so this is my policy, auto policy configuration. I will, if for the memory utilization rule, I would add one instance if my average memory utilization exceeds 60% for 500 seconds. So if for 500 seconds my memory utilization, the one that I have allocated to my application, is going to exceed with 60% the normal, a new instance will be added. If instead my application is not so used, then I should remove an instance if its utilization is below 30%. And more rules like this can be added, and you can increase the minimum instance count or the maximum instance count, you are never going to get like 0 instances because you will have at least 1 instance running for your application. And you can just add as many as you want like this, but be aware that if you just add many, you have to keep in mind the conflict between them. And this is how you just get rid of the idea that your application at some point might need more resources in order to run and to serve its users in a certain amount of time. Getting back to the factors, there's a thing, and it's a very important part for your application, is the disposability of your application. What this means is that at some point in time, it can happen that you need to stop your application because you need to make a new deployment, or you have to make a change in your code. And this has to happen very fast. Your users do not need to know, so you do not want to show to the users that page saying your application is momentarily not available, and they have to wait an F5 for a long time. Now the cloud, it helps you of having a fast startup and graceful shutdown, but you can achieve this by actually having in mind to push to the cloud only the resources that you need. So to keep in mind that for an application that, I don't know, has a lot of images, to do not have the necessity to push all the images to the cloud in the same WAR that you are making for your application. You just can simply store the images for your application in an object storage and just specify the URL to that object storage and get those images. So this is how you maximize the robustness and have a fast startup and a very easy shutdown, because at each startup, your application will not need to build the big WAR with so many resources and to I don't know, to have problems into starting, because it's a big WAR file or a big ER file in case of a Java application. And this can be applied also for Node.js, because images can be really big. And what I told you in the beginning is that one of the scopes of this methodology is to have this dev-prod parity. I mean, to have the development as similar as possible with production. And this can be done because there is actually no difference between the deployments. The same commands can be used for various deployments. Maybe the route, I mean, the host name can change because you are choosing to change that host name. But in the end, you're going to use the same command. You do not have to think that an installation is particularized for your dev and an installation has to happen for production. So I'm just going to show you in my browser the comparison between those. So for example, actually I'm going to look into the Node one. So this is the deployment on dev for the Node application. And you can see here my application name is book node. And I'm using this simple command, cf push cf up. Name of the app is going to take the name of the app and is going to push it to the cloud. Now, for a deployment in another place, for integration deployment, for example, what I would do is to have the same command. What is different between those two is just the place of the deployment. That's actually not my concern. And this is how you can have the same commands no matter of the deployment target that you are having. You can see they're having the same stuff. But they're using different databases, by the way. The next factor that's very important for us as developers is the log file, because the logs are actually helping us in debugging or bug fixing. Most of the time the bugs are being reported and we are investigating them based on the log files. In case of the cloud, the log files should never be managed by us, because this is something that belongs to the cloud platform and we cannot intervene. We can filter among those to see them, but there's nothing that we can control. So never rely on the cloud log files. But what can you do to make the debug? You can use the IDE plugins like I am using in my Eclipse. So you have here my application in Java, and I can enable application debug because I'm in development mode, and I can develop very easy and debug very easy. The application that exists on the cloud should write something in the console, but it doesn't because of the internet. So using the IDE plugins, you can debug the application that you're having deployed in the cloud, but never rely on the log files or just, I don't know, trying to manipulate those log files from there. And in terms of audit, because for such an enterprise application, the audit is very important. Well, for audit, I suggest using third-party libraries like Logstash, Splunk, Fluent. Fluent and Logstash, I think that are open source, they're for free, so use them for auditing. And it's pretty nice to use them in conjunction with the cloud applications because you do not actually put everything in one place, and you're just having more modules connected to your application, and you are just extracting what you need from your application, not just having a lot of log there in the same place. And the last factor is the admin processes. So with the admin processes, I'm referring here to those processes like when you are starting an application and you are initializing the database for an application, you're usually having a script that you're, I don't know, somebody executes it, or there is a certain task in cron that executes that script. Well, in order to configure this admin processes, it's better to externalize them from your Java code or Node.js code. So in my case, you can see here that I've configured my database initialization with the data.sql that's being executed once the application has started up. So there's no need into coding it or hard coding it to the Java code or to the Node.js code. This is just the application, the properties of the Java, but the same thing can apply to the Node.js code. And there's no need to just crowd the code in order to just make one process to run from time to time. Let's talk a little bit about the advantages of the 12-factor app. So the main advantages of this methodology is that the time between deploys is hours. And I'm not talking here that in a traditional app you are actually taking a week to deploy an application. I'm talking here about the part that you can see more rapidly what you have developed or what the team has developed, because you have continuous integration and continuous deployment, and you can see at any point in time what is the status of what you're developing. You're not waiting until the end of the sprint to see that. You do not need to have different persons to deploy an application because the application is deployed automatically once you have set it up a pipeline. And your difference between production and development is not existing anymore because those environments are as similar as possible. And because of the scaling, you do not have to worry about the performance. And I want to thank you and to invite you to ask me questions. If it's about resolution, I'm sorry, my computer doesn't have an HDMI, and I'm sharing as best as I can because I wanted to share also the coding part with you, and I have given up to the resolution part in order to do that. So please ask me. Yes?
You said that you will know it is no more needed to have properties application to application level. How that database resource will be seen into the application?
Well, for my Java application, for example, that's it's going to be seen through the, actually, no matter the programming language, it's going to be seen when it's binded. So when
like
pushing the app,
GNDA name, or
it's like a GNDA, yes. But that GNDA name, it's actually the label, the name of the service that is as a service in the cloud.
So to the level of cloud, the resource has a specific name, and that one is used into the application.
Yes, that name you can choose, by the way. So you choose the name. I choose to call it BookDB, and that my application is going to look for a database service called BookDB. That's it. It doesn't concern on any other part.
And about debugging,
yes,
without having access to environment logs, let's say.
Okay.
It's not tricky to do things like so, because there are some errors related with the resources to a specific environment.
I haven't seen that happening. So because you're not your application is a little bit agnostic of the environment, so it's not going to care that much. If your application ran and was deployed, you can be sure that it's not going to have errors specific to the environment. The environment part is actually, and the operating system is actually the concern of the cloud provider. So the cloud provider is making that for you. It's not your concern anymore. You just bring the code and the data for your application.
So when your application is not able to connect to specific resources, some kind of cloud monitoring tools will respond, or?
Yes, you have monitoring in the cloud, and you can you can monitor the application. I can show you.
Okay, thanks.
Welcome. Any other questions? Just want to show you the part with the monitoring. Okay. So there is also a thing called monitoring here, and any cloud provider has monitoring, and you can monitor what happened to your application, and you can view what happens to your application. You can also have logs, and you can filter among them. Please ask me questions, because we have some time left, and yes. What do you well, the same configuration variables, I mean, you're using the same services in development and production. The only difference is going to be that perhaps the amount of services that you're going to use in production. So you're going to have more instances of a certain service in production. Well, for that, there has been done, I think it's called, there are stress testing as a service stuff in the cloud. So in IBM Bluemix, we have a service called Load Impact, and you can see the impact of a lot of requests to your application by simulating that. So that service creates scenarios, and there are many other these kind of services that just create multiple scenarios, thousands of scenarios, and are just hitting your application. And actually, this is how you're testing also the auto-scaling policy, because you're going to see that when a lot of hits are coming to your application, the auto-scaling takes action and is going to raise the number of instances or the number of resources for your application in order to keep it up and running and available there. So usually you're doing that by stressing it with load testing as a service. Any other questions? Yes?
Standard API, or what kind of API when you say?
In my case, what I've shown you today, it's related to Cloud Foundry, but I have investigated a few other cloud offerings from others, and they pretty do the environment variables in the same manner. So this is kind of I don't know, a standard to call it. So it's like simple expression language, or that it was adopted by all those that make the cloud. Because if you want to, I don't know, to have more users, you want to allow a fast migration from a cloud to another. So this is kind of adopted between the clouds. It's not something depending on the Cloud Foundry. like a general rule, general availability.
And to run locally, you said you need to...
Yeah, to run locally, I'm going to show you. So for my Java application, I've used the Spring Cloud Bootstrap properties, and I'm having here Spring Cloud properties. That's on local part, where I say the local URL and so on. So this is how I run my application locally. This is going to be ignored in the cloud. So these two get ignored in the cloud, and in the cloud, only these are being taken into account. Only what is here. So I have just played a little bit with the Spring Cloud, and so locally I'm using these two in order to connect to my database locally, or I just can, it's not recommended, but you can also take the URL of the database as a service and just connect it from it locally and use it locally, for development, but it's not that recommended to do so. But these two are working only locally, totally ignored in the cloud. I've tried it.
Okay.
Any other questions? Well, thank you. And thank you all for coming. It meant a lot to me to have so many people listening to me today. Hope to see you soon.